Cancer is very preventable. It's a very preventable disorder. It's just that we're doing everything we possibly can to induce it in our diet and lifestyle.
A lot of big institutions believe that cancer is a genetic problem. You believe otherwise?
The evidence is striking. I mean, it's not whether you believe, it's what the data tell us. Okay, so according to the somatic mutation theory of cancer, mutations in the nucleus lead to dysregulated cell growth. That's the somatic mutation theory. In the mitochondrial metabolic theory, it's a transition from oxidative phosphorylation to a fermentation metabolism inside the cell. The mutations are largely irrelevant. What do you mean by that? When the mitochondria become defective, they throw out ROS, reactive oxygen species, that are carcinogenic and mutagenic. Whoa, what does that mean? Causing mutations. So a lot of the mutations that we see in the nucleus of the tumor cell, that is the subject of the somatic mutation theory, are downstream effects of the dysfunction of the mitochondria. So the mitochondria is causing a downstream effect, which are mutations, which are, according to the somatic mutation theory, are the cause of the dysregulated cell growth. Let me tell you why that's absolutely untrue. There's some cancer cells growing out of control that have no mutations and normally not discussed. Well, how can that be? That's a challenge to the theory. If the theory says that all cancers have mutations and you have some cancers that have no mutations and they're growing out of control, that should say, whoa, bell ring one. Then the somatic mutation people who think this, said, okay, we have a problem here. Not all mutations are the ones that cause the dysregulated, only some. And we have a name for those some. That's called driver mutation. Oh, okay, now it's a nice term. Because some of those mutations are called passengers. They don't really do anything. But the drivers are the ones that lead to the dysregulated cell growth. So we should be focusing our attention on these driver mutations. New evidence from the recent scientific literature, can you believe this? They're taking normal tissues from patients, different organs and things like this, from normal people, no cancer, perfectly healthy, like yourself here. We would take tissue from you and say, oh my Christ, look at you got driver mutations in your esophagus and your different parts of your body, you got driver. But you don't have a tumor. What's going on with that? How you explain that these driver mutations are causing dysregulated cell growth when we have thousands of driver mutations that are there that are not causing dysregulated cell growth? Oh, okay, that's another problem. The biggest devastating information against the somatic mutation theory is if you take the nucleus from a tumor cell, cleanly take it out of the tumor cell, and you have another normal cell here, you take the nucleus out of the normal cell and you put the tumor cell into that cytoplasm, you get regulated growth, no dysregulated growth. But if I have the normal cell and have a tumor cell, take the tumor nucleus out of there and take the normal nucleus and put it into the tumor cytoplasm, which contains defective mitochondria, dysregulated cell growth. This has been seen over and over and over again.
So just to summarize that, so if you take the tumor nucleus out of the cell and put it into a normal healthy cell,
yes,
everything's fine.
Everything is fine.
But if you take healthy cell nucleus and put it into a tumor cell,
yeah,
you still have the same
dysregulated cell growth.
Tumor growth. So which means that it's not the nucleus.
Absolutely.
It's something else.
It's something else, and that's the mitochondria. And I told you, then you have cancer cells with no mutations, and then you have driver mutations in normal cells that never become cancer. You put all those things together, and you have to be a hopeless ideologue to think that cancer is a genetic disease. It's a silent assumption in the field that cancer is a genetic. Every textbook of biology, cell biology, and biochem, cancer is a genetic disease.
Why hasn't people's opinions changed despite the evidence that you present?
It's a very difficult thing. It goes back to when you have one theory replacing another theory. It's called paradigm shifts. And in history of science, paradigm shifts have been met with great resistance. The clearest one was the Copernican revolution, when for 1,800 years, astronomers in our early astronomers thought the Earth was immovable in the center of the solar system. For 1,000, this was Claudius Ptolemy, Aristotle, and the Bible, and all these. Earth is immovable, and the sun and the moon and the planets all revolve around the Earth. 1,800 years. Even Copernicus was working with these mathematical formulations. As Kepler was being constantly confused until he said, what happens if we put the sun in the center of the solar system and consider the Earth as simply another planet that would revolve. All of a sudden, things started to make sense. And Giordano Bruno, a theologian, was put to death for suggesting that Copernicus was right. There was a tremendous resistance on the part of the Roman Catholic Church at that time. And this is the same thing that happened when Louis Pasteur said the germs, rather than bad air, are the cause of disease. So, and when Darwin Wallace's theory of evolution came, it's not special creation, it's natural selection that can explain this. These were massive paradigm changes in the history of science. And what we're seeing today is the same thing. The mitochondria is the center of the problem with cancer, not the nucleus. The mitochondria, it's a mitochondrial metabolic disease. And once you realize that, we're going to drop these death rates massively in a number of years for sure.